Mm-hmm.
Hello everyone, I hope you're doing well. In this video, we are going to convert the Miller indices into miller-bravais indices for directions. And we can see we have a lot of different kinds of directions: positive, negative, all negative, few positive, few negative. So we'll be doing it for all kinds of cases. And let's quickly get started and see how we can do that. And basically, we are converting the 3-index system, which is Miller indices, into 4-index system, which is miller-bravais indices. Let's quickly get started. And first of all, we should clarify on the notation that we are going to use for Miller indices and miller-bravais indices, because obviously we are doing that transformation and we should stick to that notation throughout, and you can use your own. It's totally optional. And first of all, since Miller indices are 3-index system, so we'll have 3 indices. And the first index, I'll be representing the first index by h prime, second by k prime, and the third by l prime. All right, the first index refers to x index, second is for y index, and the third is for z index. And if you refer to the HCP coordinate system, then it's a1 for the first, a2 for the second, and z axis for the third. Okay, if you know, then you know, but it's totally fine to imagine them for x, y, and z axis as well. That's totally fine. And we can see that these are the notations for the Miller indices: h prime, k prime, and l prime. The first index will be h prime, second will be k prime, and the third will be l prime. Whereas in miller-bravais indices, we can see that there are 4 indices, and there will be one extra index in here. We'll see where it goes. And corresponding to h prime, the first index will be h in miller-bravais indices. Corresponding to k prime, there will be k index. Okay, and after k index, there is an extra index which is I index. Okay, and that is not present in Miller indices. And then we have the last index L prime, which corresponds to L index. So H index is for A1 axis, K index is for the A2 axis, L index is for Z axis, and I index is for A3 axis, which is the extra one. Okay, if you want to compare it with the coordinate system that determines them. So yeah, the thing that you should remember is H prime, K prime, and L prime for Miller indices, H, K, I, and L for the miller-bravais indices. All right, and we will write them in that order as well. For example, first will be H index, second will be K index, third will be I index, and the fourth will be L index, enclosed in these square brackets. Okay, similarly here it's H prime first, K prime second, and L prime last. Here we go with the first direction, and we can see it's 2 1 0. This is H prime, this is K prime, and this is L prime. And we can see that that was really simple. We can write them here like H prime equals 2, K prime equals 1, and L prime equals 0. These are the Miller indices. Now we need to calculate H, K, I, and L. Okay, there must be a formula. Let's write down this formula that we'll be using. We know that. Let's write down those transformation equations that we will be using to calculate H, K, and I, L. So H is actually equals to H is equals to 2 times H prime. If it's H, then you will write 2 times H prime minus K prime divided by this whole thing divided by 3. If it's K, the formula is same, 2 times K prime minus H prime divided by 3. It's really simple. They are almost similar. However, they are shifting, reshuffling of values in an ordered way. So you can remember that you can you can remember it really easily. Like I told you, H equals 2 H prime minus K prime, K equals 2 K prime minus H prime. That's just the changes. I equals negative of H plus K. Okay, you'll calculate these two first and then you'll add them up. Negative of it is I simply, and L is equals to L prime. It doesn't changes. I can call it as 1, 2, equation 3, and 4. Let's calculate H from 1. Putting values into 1. So H equals 2 H prime. What is H prime? It's 2. Minus K prime, which is 1. Okay, 2 H prime. H prime was 2, so minus K prime, which is 1. and this whole thing divided by 3. 2 2s are 4, minus 1 divided by 3. 4 minus 1 is 3 divided by 3. 3 cancels out and it's 1 left. So h equals 1. Now putting value into 2 to calculate k, we can do it here. So k equals 2 times k prime, which is 1, minus h prime, which is 2, divided by 3. K equals 2 minus 2 divided by 3. 2 minus 2 is 0. So that is it. K equals 0. Next we have I, which is given by minus h plus k. Minus into h was 1 plus k was 0. The new ones, okay? And it's minus 1 and it's minus 1. Simply I equals minus 1 while L equals L prime, which is 0. You can see here. So in that way we have calculated all of these 4 miller-bravais indices. Now let's write them in final form. These are the final miller-bravais indices because we can see that there are no fractions involved and also they are in least integer form. That is why these are the final numbers. In next examples, we will see that these extra steps will be needed when they arrive. So for now, we can see that they are the final miller-bravais indices. Let's write them down. So we can write it in here. I'm just saving the space. We have h, k, I, L to be equals to, first is h index that we got 1. Okay, so it's 1 for h, 0 for k. I is actually negative 1, so it's 1 with a bar over it to show negative number. We put a bar over the number when we are writing down their Miller indices form in bracket form. So L is 0. These are the miller-bravais indices for these Miller indices set. Secondly, we have this set. This is h prime, this is k prime, and this is L prime. These are the Miller indices. Now let's convert them into miller-bravais indices. So let's officially start solution. And we have h prime to be equals to minus 1. Alright, this is a bar over it, so it shows that it's negative. Next we have k prime to be equals to 1. Next we have L prime to be equals to 3. And we need to calculate h, k, I, and L. Alright, so let's write down those transformation equations. We know that h is equals to 2h prime minus k prime divided by 3. K equals 2k prime minus h prime divided by 3. Alright, I equals negative of h plus k, while L, my favorite one, is equals to L prime. Nothing changes for L. So let's put values for h. Putting values for h. So h equals, we have 2 times h prime, which is minus 1, minus k prime, which is 1, divided by 3. So it's 2 into minus 1 is minus 2, minus 1 divided by 3, minus 3 divided by 3, 3 cancels out and it's minus 1 at the end. So h equals minus 1. Next, putting values for k. Values for k. Putting values, okay, write down value here. So k prime equal, k equals 2 times k prime, which is 1, minus h prime, which is minus 1, divided by 3. So it's 2 ones are 2, minus minus plus 1 divided by 3. 2 plus 1 is 3. So 3 divided by 3. 3 cancels out and it's 1 at the end. And we got k equals 1. Putting values for I. And I equals negative of h plus k. H is minus 1 plus k, which is 1. So minus 1 plus 1 is 0. Negative of 0 is 0. So it's simply I equals 0. Alright, and for L equals L prime, that is equals to 3. It remains the same. Alright, so we can write down the final Miller indices. The final miller-bravais indices are the miller-bravais indices for 1 bar 1 3, or you write down the final results, which are actually H. H is -1, so it's 1 with a bar over it since it's negative. Then we have K, which is 1. Then we have I, which is 0. Then we have L, which is actually 3 again. So this is the answer. Let's do it for the next one. Next we have this set. We have H prime. The first index is H prime, second index is K prime, and the third index is L prime. And let's quickly get started and see how we can convert them into miller-bravais indices. First of all, we'll write down the data. H prime is 0, K prime is 1, and L prime is 1 as well. And we need to calculate H, K, I, and L. Okay, that is something that we need to calculate. And let's write down the formula that we are going to use. We know that these are the magical transformation equations, which is H equals 2H prime minus K prime divided by 3. This is H. Then we have K, that is actually equals to 2K prime minus H prime divided by 3. Then we have I, that is equals to negative of H plus K. Alright, so let's put values for H now. Putting values for H. Okay, so H equals 2 H prime, which is 0, minus K prime, which is 1, divided by 3. 2 zeros are 0, minus 1 divided by 3, and it's minus 1 divided by 3 at the end. A fraction is involved. We'll see how to deal with it at the end. Next is K. Putting values for K. And for K, 2 into K prime is 1, minus H prime, which is 0, divided by 3. So 2 ones are 2, minus 0 divided by 3, and it's 2 by 3 at the end. Next we have I. Putting values for I, and we got minus H plus K, which is minus 1 by 3, which was H, plus K, which is 2 by 3. Let's add them up. It's 3 as LCM, minus 1 plus 2 is the numerator, minus 1 plus 2 is 1 by 3, and this negative is already there, so it's minus 1 by 3 as I. And lastly for L equals L prime. Putting values for L, and we have L equals L prime, that is equals to 1, simply. Okay, so the value of L is 1. Now we can see that we have fractions involved in here. It's minus 1 by 3, 2 by 3, minus 1 by 3, and 1. We need to remove these fractions before we write them down in the parentheses form. So we'll have that table in here. Let's write them down. It's H here, K here, I here, and L. Let's write them down, whatever we have got in here. So it's minus 1 by 3, it's 2 by 3, it's minus 1 by 3, and it's 1 here. Next, you will write down here the operation that we are going to perform, and it's multiplying with the LCM of denominators with the LCM of denominators. Okay, we can see that it's 3 in the denominator, and hence we'll be multiplying with 3 with each of these indices. Okay, so doing so will remove the fraction, because fractions are not involved, are not allowed in writing down the Miller indices or miller-bravais indices. So we'll multiply with 3 with each of these indices. Okay, whatever the LCM of denominators is, we can see it's 3 denominator, 3 denominator, and 3 denominator. And if you take LCM of 3, it's 3 only. So 3 3 cancels out, 3 3 cancels out, 3 3 cancels out, and it's 3 ones are 3. So finally we have got -1, 2, -1, 3 ones are 3, so 3. And these are the final miller-bravais indices. H is -1, K is 2, I is -1, and L is 3. We can see it's quite different and quite unexpected as well. So let's write down their final miller indices. So the miller-bravais indices, Bravais indices, or these are actually HKIL to be equals to -1, which is 1 bar for H, okay, then 2, 1 bar again, the last is 3. Okay, these are the miller-bravais indices and for 0 1 1. Okay, this is the next set. We have H prime, second is K prime, third is L prime, and let's do the solution. And here we have H prime to be equals to 2, K prime to be equals to 4, and L prime is equals to 6. We need to calculate H, K, I, L. Okay, so we know that H is equals to K equals to I equals to L equals to. You should write them down first hand because it makes your way clearer that what you are gonna do. 2 H prime minus K prime divided by 3. 2 K prime minus H prime divided by 3. So putting values for H. So it's H equals 2 times H prime, which is 2, minus K prime, which is 4, divided by 3. 2 2s are 4, minus 4 divided by 3. 4 minus 4 is 0, so it's 0 at the end. H equals 0. Next is putting values for K. So K equals 2 times K prime, which is 4, minus H prime, which is 2, divided by 3. 2 4s are 8, minus 2 divided by 3. 8 minus 2 is 6, divided by 3. 3 1s are and 3 2s are. So K equals 2. Next is I, putting values for I. I equals minus H plus K. And it's minus H is 0, plus K is 2. So it's minus 2 at the end. And my favorite is putting values for L. L equals L prime and L is 6. Here you can see one interesting thing that we have got 0, 2, minus 2 and 6. We can see here that we can reduce them into least integer form. Like they're all divisible by 2. If we divide them by 2, we can reduce them into a least integer form. So in case of directions, you have to incorporate this thing in, into your, considerations. We have H, K, I and L. We got 0 for H. We got 2 for K, minus 2 for I, and 6 for L. So we can divide them by dividing them by 2 because they are all divisible by 2. So let's divide them and see what we are gonna get. So if we divide them by 2, so it's 0 by 2 is 0, 2 1s are 2, 2 to cancel, minus 1, and 2 3s are 6. We cannot divide them further if this is the least integer form. If you cannot divide them further, I cannot divide them by 3, there will be fractions involved. Okay, we cannot divide them any further. So that is the final form. And these are the final miller-bravais indices for the case that we are given with. So 0, 1, minus 1 and 3. These are the miller-bravais indices for the Miller indices set that we are given with. Okay, this is the next set and we can see this is H prime, K prime, and the last one is L prime. Let's see how we can do that. Well, obviously till that point you must have learned that how you can do that, but sometimes we have some interesting cases as we had with 011. So h prime equals -2, k prime equals -3, l prime equals -3, and we need to calculate h, k, I and l. Okay, and we know that the transformation equations, the famous transformation equations, it's 2h prime minus k prime divided by 3, 2k prime minus h prime divided by 3, I equals negative of h plus k, l equals l prime. So putting values for h, so h equals 2h prime, which is -2, minus k prime, which is -3, divided by 3. So 2 2s are 4, -4, it's negative, minus minus plus 3 divided by 3. -4 plus 3 is -1 by 3. So h is -1 by 3 so far. That's not final, we'll see later. And putting values for k, so k equals 2 k prime. K prime is -3 minus h prime, which is -2, divided by 3. It's 2 3s are 6, -6, minus minus plus 2 divided by 3, -6 plus 2 is -4 divided by 3. Okay, so k equals -4 divided by 3 so far, not final, so far. Then we have I, that is equals to minus h plus k. Okay, so it's minus h, which is -1 by 3, plus k. Okay, we'll simply write minus because it's minus, so it's -4 by 3. Let's find out the LCM. It's 3 minus 1 minus 4, and it's -5 by 3. I equals -5 by 3, while L equals L prime, which is -3. We can see here it's -5 by 3 and it's negative here as well, so it will become positive. This minus and these minus will become positive. Minus into minus is plus, so it's +5 by 3. And we can draw the table here. Okay, here we'll have h, here we have k, I and l. Okay, so for h we got -1 by 3, for k we got -4 by 3, for I we got +5 by 3, and L equals -3. Now we need to remove these fractions, and we can do this by multiplying the LCM of denominators by each of these indices, and we can see that it's 3, 3 and 3 in the denominator, and if you take up the LCM, it's 3 ones are 3 ones are 3 ones are, and it's 3, 3 is the LCM. Multiplying 3 by each of these indices to remove the fractions, and so this 3 3 cancels out and it's -1 left behind. 3 3 cancels out, -4 is left behind. 3 3 cancels 5. -3 into 3 is -9. So these are the final Miller indices we have. HKIL, that is equals to H is -1, 1 bar, K is 4 bar, 5, 9 bar. These are the miller-bravais indices for 2 bar, 3 bar, 3 bar Miller indices. This is actually the last set. This is H prime, K prime and L prime, and we have H prime to be equals to -1, K prime is -1, L prime is 1, and again we need to calculate HK, I and L. We know that H equals K equals L equals, oh, I is also there, minus H plus K, L prime, to H prime minus K prime divided by 3, to K prime minus H prime divided by 3. Simple as that. So putting values for h prime is -1 minus k prime, which is -1. We'll use brackets whenever there is negative number. 2 into 1 is -2. Okay, minus minus plus 1 divided by 3. -2 plus 1 is -1 by 3. So h equals -1 by 3 so far. Not the final one, but so far. Putting values for k equals 2 -1 minus -1 divided by 3. Since h prime and k prime are same, so you'll get the same result, -1 by 3. You can find out the LCM. It's completely same. So k equals -1 by 3 so far. Then we have I. Putting values for I, it's minus into h plus k. So minus into h is -1 by 3 plus k is -1 by 3. So it's this minus into 3 -1, so it's minus into -2 by 3 minus plus, so it's 2 by 3. Okay, whereas L equals L prime, that is equals to 1. You can see here. So let's draw the table and remove the fractions. Okay, h k I L, and we have -1 by 3 -1 by 3 2 by 3, and it's 1 in here. We can see again we have 3 as the denominator, so multiplying with the LCM of the denominators, which is, if you take the LCM is 3 simply. So multiplying with 3 with each of these indices, because mathematically you have to do a process on everything to neutralize the effect. Okay, so 3 cancels out and it's -1. 3 cancels out, it's -1. 2 3 ones are 3. So these are the final Miller-bravais indices. We have HKIL to be equals to 1 bar, second is 1 bar again, 2 3. In some instances you can also write it as 1 1 and a single bar over it if they are coming consecutively, and like that. Okay, so these are the final Miller-bravais indices, and I hope you got it. The process was really simple. The only thing that you have to do, like, you should know what is h prime, k prime, and l prime. Use the equations, the transformation equations, like that. These transformation equations, put the values and find out h, k, I, and l. If there are any fractions involved, remove those fractions by using this table. Multiply with the LCM of denominators, the fractions will be removed, and at the last time you have to see that whether they are in least integer form or not. If they are in least integer form, then the indices that you have got are the final Miller-bravais indices. All right, so you always reduce them into least integer form when you are considering the directions. It's because the direction C and a multiple of it, a scalar multiple of it, they are all similar. That is why we reduce them into least integer form. So yeah, that is it. So that is it for this video. Like, share, and subscribe. And if you have any queries, you can ask me in comment section. Well, take care and goodbye.